Okay, welcome once again to Isifedu blog. In this particular video, we'll be treating another type of machine, which is the wheel and axle. So always remember to subscribe, share, and like. Now what we have here is the diagram, a simple diagram of a wheel and axle. This is how it looks. Now what is a wheel and axle? It is a machine that consists of two cylinders. You can see the two cylinders. Two cylinders of different radii. So you have one cylinder and another cylinder. Two cylinders, this is the bigger one. Then we have the smaller one of different radii, which are joined together at the ends. Now what we use this, of course, so many people use it for cooling. As we are drawing water, use it to draw well. As we are drawing, the water comes out. So this is the load, the bucket, where you attach your rope to it. As you are drawing, applying your effort towards this end, it is lifting a load at this particular end. Now the next thing we need to do now is, what is the velocity ratio of this particular machine? So look at what you need to do. It's very easy. The velocity ratio of our wheel and axle is simply the radius of the wheel, which is the bigger cylinder, the radius of the bigger cylinder, divided by the radius of the axle, which is the smaller cylinder. So the velocity ratio of wheel and axle is the radius of the axle, of the wheel, which is the big R, the radius of the wheel, which is the big R, divided by the radius of the axle, which is the small r. Very simple, no much problem on this. So we have the velocity ratio as the radius of the wheel. As you can see, this is the wheel, divided by the radius of the axle. So we are going to just solve one question about the wheel and axle. For more exercises, we are going to meet that. Let's use this and see how to apply this particular formula when question comes. Okay, we are going to make use of this question to explain wheel and axle. Now, the question here says, a bricklayer drawing water from a well uses the wheel and axle of the well. The weight of the water is raised. The weight of the water raised is 500 Newton, using an effort of 200 Newton. The wheel and the axle have the following radii: 600 millimeter and 200 millimeter. Remember, the radius of the wheel is the bigger radius, while the radius of the axle is the smaller radius. So we are now asked, what will be the efficiency of the system? Remember, I've always said that efficiency is a standard formula. So we have that the efficiency in this question, we are making use of the second formula for efficiency. If you missed our tutorial, please go to Isifedu blog. So efficiency, we know, is mechanical advantage divided by the velocity ratio times 100 over 1. We need to get the mechanical advantage is not a problem. We also need to get the velocity ratio. So what is the mechanical advantage? Mechanical advantage is equal to load over effort. The load raised is 500. The effort applied is 200. 500 divided by 200 should be giving us 2.5. It has no unit. This is giving us 2.5. Now we need to get our velocity ratio. Our velocity ratio is, for wheel and axle, is distance moved by effort, which is this over this. So what we have here is 600 divided by 200. This will give us 3. So our velocity ratio is 3. Mechanical advantage 2.5. We just need to pick these two values and impute here in our formula to get our efficiency. Therefore, our efficiency will give us, mechanical advantage is 2.5. Velocity ratio is 3 times 100 over 1. So 2.5 times 100 divided by 3 will be giving us 83 83.3%. 83.3%. So the efficiency of this particular system with this particular information given to us is 83.3%. If there is any confusion here, please drop your questions in the comment section. I will attend to that. We go over to the next machine. But for more exercises, click on the exercise section. You are going to see many questions on Waec and Axel.